Are you ready for the second part of our PREEvision systems engineering tutorial? Great! Today we will take a look at the functional viewpoint of this little guy here. Now I will demonstrate how to model a system from the functional viewpoint. Then I will show you how to link the artifacts of the functional design to system requirements, to test specifications, and to the logical architecture. Let's begin. To model our system from a functional viewpoint, we open the System Architecture category of the Systems Engineering Explorer. Here, we open the Functional View package that contains the functional viewpoint of our robot vacuum cleaner system. In the Functional View package, you can create functional activities. To open the corresponding functional activity diagram, double-click on the functional activity. For example, let's open the diagrams of the collision avoidance function and of the terrain awareness function. To get more information about the model when exploring a diagram, we activate the Show Tooltips option in the Diagrams toolbar. Now, when we hover over a diagram object, an optional description and the object's type, such as action, activity partition, or control flow, are displayed. For example, let's look at the Calculate Distances action of the Terrain Awareness activity. The diagram states that the calculation of distances to boundaries or obstacles is triggered by changes in the robot's position and motion vector and by changes in the virtual boundaries or map. To add an action to an activity diagram, first select Action from the palette. Then we locate the new action in the diagram with a click and name the action. For example, as a failover to avoid a collision, let's add a Stop action to the collision avoidance function activity. To make the stop action dependent on recalculating the route, first we select Control Flow in the palette. We drag the starting point of the control flow to the Recalculate Route action and drop it. To show the links between the objects that are displayed in the diagrams to requirements or other artifacts of the system, select all objects in the diagram with Ctrl-A and press Ctrl-M. To make the view clearer, we can move the boxes displaying the linked artifacts. For the Terrain Map action and Robot State Acquisition partition, boxes showing links to system requirements are displayed. The tooltip for each requirement shows its name, branch, revision, and description. For the Recalculate Route action, the functional safety requirement states that the vacuum robot should not continue driving uncontrollably in the event of a possible collision or loss of connection to the base station. To link the functional safety requirement to the Stop action, we open the System Requirements link table. We expand the Robot Vacuum Cleaner composite partition, which contains the Stop action. Then we select the functional safety system requirement assigned to the Calculate partition and link it to the Stop action too. Similarly, we can link our Stop action to test specifications and to the logical architecture that will be presented in the next part of our tutorial series. To display the newly created link in the diagram, we select the Stop action and press Ctrl-Shift-M. That's it for now. That's it for functional design. In part 3, we will demonstrate how to model a system from a logical viewpoint. See you there. Would you like to check out model-based systems engineering with PREEvision for yourself? Go for it. We offer the example model from our tutorial in a hosted PREEvision environment. There, you can perform the tutorial steps yourself using PREEvision. If you are interested, please visit preevision.com/trial. Thanks for watching.